Okay, in this exciting video, we'll learn about the angular momentum of a particle. So by definition, for a particle of mass m, position vector r, and velocity v, its angular momentum, by definition, about any point P is hp is equal to r minus rp cross mv. So again, I have some particle of mass m, velocity v, position vector with respect to the origin called r. And I have some other random or any point P, basically with position vector rp. So the vector r minus rp is this one, basically. The vector from the particle, from point P to the particle. So basically, the angular momentum of the particle about point P is r minus rp cross mv. And this setup should remind you of the moment of a force. So if I had a force F applied at the particle of mass m, the moment of the force F about P, the moment of the force F about point P would be equal to r minus rp cross F. Oops. Cross F. So really, basically, what the angular momentum is, or a better name for the angular momentum, is just the moment of the linear momentum, right? mv, which is g, the linear momentum. So a better name for the angular momentum, so that you don't forget it, is the moment of the linear momentum. If you think about angular momentum this way, you should never ever forget its definition. And the angular momentum is always calculated about a point. The angular momentum about point A is different than the angular momentum about point B and C, etc.